I am going to be talking about building offline first AI tools with Gemma 3N, but just as a heads up, that is the official title. But um, I actually want to try and approach these two projects that I'll be sharing today less as specific tools and kind of more as like generalizable patterns. And there are patterns that can emerge when you start building systems that are specifically with offline language models in mind. And also, we'll be looking at one more offline model besides Gemma 3N today as well, because while the Nano is, I think, very impressive and very fairly mighty, once you start looking for outputs beyond just natural language conversation, it can get tricky pretty fast. And so that's for fairly intuitive reasons. But to understand why, maybe more specifically, I'm going to quickly review how the big well-known LLMs actually come into being. And this is super intimidating to do in front of my mentor, Shah, from whom I actually first learned all this. So we'll give it a shot. But visualizing LLMs for me is a real challenge because I'm not really looking for something that is techno-mystical, anthropocentric, or even more confusing than whatever I had in my head before. So just like 99% of my coding for the time being, I'm just going to focus on capturing the vibe. And here I have an Escher image because honestly, to me, large language models feel very Escherian. It's like step by step along the way, every piece of the composition, every mechanism makes sense. But then when you zoom out to look at the whole thing, it's like, how does this hold together? Like, how this isn't really supposed to work. So there's something of that kind of like impossible machine energy into it. So I'll just keep that up there to capture the energy. The life cycle for the large language model begins with a massive text corpus, but the model actually doesn't read this text directly. The first step is a process called tokenization. And tokenization is not carried out by the neural network at all. It's just an algorithm, and it takes that raw text and it processes it into units called tokens. And they're small enough to capture like the meaningful subparts of language, but they're also large enough so that the model doesn't completely explode. And a common approach is something called byte pair encoding. And it starts by treating every character as its own symbol and then repeatedly merging the most frequent pairs of symbols until it has a full vocabulary. The engineers, I guess, can decide on what that will be. So maybe 50,000 tokens. And this can depend on the model. So each token then becomes an ID number. And the model, the neural network, only ever sees these integers, never the raw text itself. Then we enter the world of the neural network. So those token IDs get passed into something called the embedding matrix, which turns each token into a vector. And a vector is essentially like an abstract direction that captures meaningful or like subtle meaning relationships that the token has across all of language. And so the width of the embedding, which is the number of numbers in the vector, so in these columns, this determines how much nuance the model can capture and how many latent aspects of context and semantics the model can include. So these numbers, these token weights, are also important to note, it's initially random. So the width also determines the dimensionality of the geometry of the meaning space. And this is a reduction of that, and we can't really conceptualize it or perceive it. And very challenging to represent. And so the larger it is, the more fine-grained token positions can be in relation to each other. Versus like more crudely clumped. So imagine if you're like moving an arrow in like high resolution space versus like if you only had like 8-bit space to move an arrow in, right? So, during training, these vectors are passed through the transformer architecture hidden layers. And a process of learning and correction that's called gradient descent then nudges the initially random weights or directions so that the tokens that appear most often in similar contexts end up with similar vectors, so pointing in similar directions. And so in the end, that collection of trained weights frozen in place after learning from billions upon billions of examples, that is central to what we call the large language model. But of course, these trained weights are inseparable from the architecture as well. The LLM is the specific transformer design and the billions of learned parameters together. And so all of this requires massive physical infrastructure to even exist, which brings us to the cloud. And with billions or even trillions of parameters, all of which must be loaded into memory simultaneously during inference, LLMs require specialized GPUs and a whole bunch of other things that I can't really speak to, and an incredible amount of compute. And that's just to serve one user. So imagine serving millions of users at the same time. And so all this means that the model has to live in this kind of apocalyptic looking data center. The cloud is basically just remote hardware plus software that virtualizes that hardware, and plus networking. So it becomes a way for us to access machines that we could never fit in our homes or in our backpacks. But what would need to happen if we do want a model that can run on a consumer device? So we'll have to shrink the model. There's no way around that. The embedding dimension goes down. Sorry, and that's a random image from a Spanish artist exhibition that I saw recently that I really liked, but I don't know. I immediately thought of my like LLM teammates and Little Gemma 3N. So the embedding dimension goes down. And so tokens that mean different things are going to get squished together in the meaning space. And that can cause ambiguity problems at the input level because the model can't distinguish the subtle differences in what you're asking, as opposed to if it had more parameters. The parameter count drops dramatically. And so this affects the model's ability to hold complex reasoning chains in mind and to generalize. And it also creates a more brittle ability to handle ambiguity at the processing level, because without as much reasoning, the model can't really think through, okay, what did they probably mean as well? And then architectural nows become conscious design decisions rather than defaults, because you're no longer taking the architecture as a given. You're constantly negotiating. Do I want more depth for better reasoning, or do I want more speed, a longer context window, or lower power usage? Or can I afford multimodal inputs, or do I need to stay text only? So every choice is a trade-off. But now for the upside, because there are very real and very meaningful advantages. First one, we can start with the unromantic truth. Offline models are free. And so when you're prototyping and making mistakes and trying a whole bunch of weird things, that is definitely a gift. Secondly, consistency and agency. So cloud models are always changing. They're getting updated, optimized, aligned, realigned, and sometimes for good reasons, but not always in ways that might match your values or your use cases. The third is privacy. Now, okay, nothing is perfectly private. Of course, laptops get hacked, devices get stolen. But to me, there's a real value in knowing where your information lives and that you are the one making the sovereign decisions as to how it can be used and to whose gain. And then fourth, reliability, the obvious. Offline models simply work wherever you are. And this is great when you might be traveling in a new country with flaky SIM activation and questionable Airbnb Wi-Fi sometimes. So it's nice when your tools don't suddenly stop working because you don't have an internet connection. A reasonable question to ask at this point is building with offline models really that different from building with cloud APIs? Is it matter of just swapping endpoints? So as I share the two offline first projects that I've been working on, we can keep this question in the back of our minds. I'm genuinely curious as to what you all think because I actually have not built with cloud APIs yet. And since I'm actually missing that piece, I can't definitively say what's different. But the goal today is to share what architectural patterns have emerged since I've committed to offline first from the beginning. So the first project is called Tillbot, and this was actually a project from when I was in Shaw's last AI Builders Bootcamp. So it was at the end of the summer, which feels like a million years ago. The way I described it in my submission was it's a personal financial assistant, a Telegram bot for expense logging on the go. The transactions are processed locally with Gemma 3N for intelligent categorization, as well as reflection and data-driven oracular proclamations, aka haikus, sonnets, and limericks. Basically, imagine if Shel Silverstein, John Donne, and a magic 8-ball got a hold of your bank statements. And so we're just gonna watch a minute of this. If I don't totally mess this up, I'm so afraid now. All right, let's see. Okay, so we're still here, but now I can't see the bar. All right, it's just a minute and let's see if the sound comes through. Ecosystem. First, there's Mycelium Till, a cloud-based Telegram bot. I can text whenever I buy something or earn something. Mycelium logs it, confirms it, and quietly stores it for later, like roots collecting nutrients. Multi-currency, handles corrections, doesn't judge my Tsundoku problem. TreeTill is the wise elder back on my laptop, running Gemma 3N locally. It reads all of Mycelium's collected messages, categorizes everything intelligently, and maintains both my expenses and assets databases. With each activation of Till for my laptop, the updates come in and the information grows like leaves. Now comes Dabble Till, the data-driven oracle shining insights through the canopy. Think of them like a rye garden spirit that offers financial counsel through haiku, limericks, and rhyming couplets. Most importantly, each poem includes actual metrics from my databases, so we get a blend of playfulness and rigor. The goal is to experience something more like a brainy magic 8-ball, a more verbose and personalized fortune cookie. Not so much conversation, since Gemma 3N is stateless. Till is more about motivation through wit and wisdom, relief against the stress and shame that usually come with money talk. And 3 practical questions after each poem point me in the right direction for further research and reflection. Okay, so that's that. Also highly suggest to everyone to consider doing a video demo as just like part of your workflow. It's really very useful for clarifying the project and also finding a whole bunch of bugs, one of which I'm going to share right now, which is that before I go over the architecture of Tillbot, I need to address a very goofy misunderstanding on my part about offline LLMs. And so in the video, I mentioned something about Gemma 3N being stateless. When I first heard this term, I thought that meant that Gemma 3N it has 0 memory between calls. And so I actually designed around that constraint. That's the reason why, that's how the whole idea of having Gemma 3N prompted for a poem came about, because poems tend to be very self-contained and they don't invite so much back and forth. Since then, I have wondered what would happen if I changed the prompt to have Gemma 3N rapping at me. So that might change it. But it turns out that olamas.chat method does contain a conversation state, but I was just using .generate, and so that starts from scratch every single time. So in any case, though, I have now stumbled on a very effective non-back and forth UX, though, because I have changed it since then to be able to have a conversation state. But I actually, with the poem, rarely feel like, I don't know, I need to follow up on the previous query. So this slide is very overwhelming for me too. But anyway, just generally trying to map the architecture of this. And really, we can think of it as personal data capture and a local AI processing loop. And this capture now, reflect later pattern is really perfect for personal data that you want to capture quickly and interpret later. And so the system manages three databases here. And here's pending messages. And this is what is in the cloud via Telegram, which is a cloud-based messaging app. And you can create bots on it. And then there are two local databases. So this is transactions and assets. And so when you boot up the program locally, you are starting the two-phase offline AI workflow process. And so in this first one is data conditioning. And what's happening here is basically all of pending messages is kind of being just in a dumb way, like copied over into the local database transactions. However, there is this moment where there's intake refinement, and Gemma 3N is used here to do some smart classification, and then it creates the category variable here. And so this is the assets database, but this is actually just a rules-based survey. It's just structured data immediately. And so then after this, there's phase two, which is the conversational interaction. And this is where Gemma 3N is generating the conversational interface. And so this is Dappletill with the poems and the questions. And so there are a few architecture-specific insights here. First, when it comes to personal data capture, I do favor having regex structuring as much as possible, even though technically you could be pretty hands-off about it, because the whole idea with LLMs, of course, is that they're magnificent for dealing with unstructured data. And when you're on the go, life is just full of unstructured things that you want to send its way. But it's helpful for two reasons, I found. One is just immediate UX feedback. It's really nice to be able to see like what some kind of, you get an idea of how whether the system's actually received the message and how, so you can do corrections a little bit. And also, I think with regex, there's better fallback if the model later miscategorizes or hallucinates. And then the second architecture-specific insight is that syncing between local and cloud requires some careful attention. So in this case, after Treetill processes a message, it updates a processed flag. I can't actually zoom in, sorry. And that will then change this in pending messages. And so it marks it for deletion and it doesn't get re-downloaded with the next batch. But above all, what Tillbot taught me is that this architecture is really generalizable. In fact, the next tool that I want to build is a voice memo system. So it's just somewhere I can send my very rambly thoughts while I'm walking, and then later have a local model transcribe it and organize it. And so this is good because I don't always want the interruption of an instant response. And I also don't want to keep deluding myself into thinking I'm actually going to go into my Google Recorder and process everything. So, okay. So the second project is the Spanish Flashcards app. And this is designed around the idea of leveraging AI assistants to handle a very tedious task, which is generating flashcards, but specifically verb conjugation cards. So Spanish language, like many Romance languages, I think probably Italian too, is it's like every pronoun, you'd have to make a card for every pronoun and then every mood tense pair. And by the end of it, you need like hundreds of cards for just one verb. And so there's a video demo too, but instead of subjecting everyone to my Spanish speaking attempts, because it's in Spanish, we're going to try giving this a shot live. So how many more things can I break? All right, so pull this up and I'm gonna go project.
Could you zoom in a bit?
Yes, I hope. Wait, I said that with too much confidence.
Command plus.
Command plus, yes. Cool. All right. And then we have it so that as long as I put in this command, so now it's running. And what's happening is this has created a, progressive web app. So now it's hosted here. I just thought to myself, oh, I should show you what it's like offline, but let's not do that. I'm not going to turn off my Wi-Fi. But it does work. And so, anyway, this is the homepage for the Spanish verb trainer. And this was the project where I learned about progressive web apps, which are awesome. Because I used to think, I was like, oh my God, how are we going to learn how to design like a native app? But a progressive web app doesn't have any installation requirements, and it's just using web-based technology, so like HTML and CSS. And so, yeah, on the homepage, we've got all of this reference guide, which is really useful because as you can see, it's a very rich language, lots of temporal nuance. So you go down here, verb conjugator. Let's say decir, which means to say, I guess. And we're going to choose the card type. Let's see, present indicative, and then generate cards. So now in the background, what's going on is Olama is loading. Oh, Aya 8B, not Gemma 3N. I'll go into why. And then we've got the cards. Let's see if it's right. Moment of truth. Digo, dices, dice, decimos, decís, dicen. Yes. Okay. Because when I tried this with Gemma 3N, that was hilarious, shall we say. And so what we can do is save cards locally, and they're going to be saved. Yeah, so this started off as just generating verb conjugations, but why not keep going? And so something else you can do is process Spanish sentences. This one takes a little longer, but I can give a couple examples. Let's say you're watching some TV show and you've got the subtitles turned on and you just want to learn these later. You can create a new set, let's say demo, and then process. I should have probably just done 2 sentences. Sorry, guys. But because I am so intent on the verb aspect of the language, especially, the Gemma 3N isn't just being prompted to translate these into, or not, sorry, Gemma 3N Aya, into English, but we'll also do corrections. So if I had not put in the accent or, I'm missing the question mark in the beginning, that should be adjusted. And also there will be some notes on conjugation. So yeah, así que pensaste. Oh no, okay. Good to know. The question mark didn't show up again. It should have. And yeah, it analyzed the verb in the sentence. Yeah, so that's generally what's going on there. Pretty straightforward. You can save these as flashcards. And then there's the whole study section. And let's say we wanted just to study the verbs. We just want to do decir. There are 12 cards that match because I have already generated that. And then you can just go through these, test yourself. You can also add them to the side stack if you're not sure and you want to be tested again at the very end. Next card. And then there's this other aspect, which is the manage cards, because if you lose track of which things you've already translated, you can find duplicates. There are 6 duplicate cards specifically for decir, and then you can delete all the duplicates. All right. Okay. So that's that app. And then there is, what I've done is made a front end. Also, I mean, it looks effectively the same, except it doesn't have the generate cards portion. And that's for the progressive web app for mobile. So like on iPad or on my phone. And that's hosted on GitHub pages. So let's see. Got it. All right. So also incredibly overwhelming. Let me try something else. Let me exit that. Okay, this might be more helpful or it might not. I made these on Lucid Chart, which I really like. I know a lot of people use Miro for drawing diagrams, but I don't know. It's just the first one that I started off with, so I can zoom in a little bit more. So yeah, we can think of the architecture here as essentially it's an offline LLM content generator with Cloud Sync for multi-device access, and it involves three main components, right? So offline first, progressive web app, and that's running in the browser, and then you've got the local LLM that's generating content in the background, and then you've got Cloud Sync. And so, yeah, you have the user that's interacting through the PWA. And then when the user requests new cards, the prompt is actually built in the foreground in the browser first, and then it is sent via HTTP post to this background process. And so it's nice to have the background, it's happening in the background because that's where heavy computation, like generating conjugations and the translations, it can occur without freezing the interface itself. So Olama then parses the prompts, loads the model, and then runs inference with Aya. And then the responses are then validated and structured into JSON objects. And then they're stored in the local indexed database, as well as they're being synced to a cloud PostgreSQL database in Railway. So that helps, that allows for the access from multiple devices. And so I'm going to get into the main architecture specific note, and I'm going to share one technical lesson. And it's not necessarily specific to offline LLMs, but it is a challenge that is amplified by the fact that it is a smaller size. And this has to do with structured outputs and prompt design. So at first, I had actually assumed that the errors in Spanish were just because of multilingual limitations and tokenization efficiency. So lower resource languages like Spanish, which is crazy to think of that as a lower resource language, but it may be less efficiently represented than English in a smaller model like Gemma 3N. And so for this reason, we switched to Aya 8B, 8B being 8 billion parameters versus just 3. And it's specifically trained on a multilingual corpus. So Aya's Spanish is definitely stronger, but even this model began producing really chaotic results when asked to adhere to strictly to the structured format. And so this led to the realization that the primary issue was not the multilingual model or the tokenization per se, but the constraints that are imposed on the LLM for structured output. And so small models struggle even more with structured outputs because they have that shallower reasoning depth, and they have a weaker ability to maintain long distance constraints. So JSON requires the ability to keep track of that long distance constraint because JSON is not a sequence, it's actually a tree, right? So the model has to actually remember things like punctuation and which keys have been opened. You have to keep track of brackets. And yeah, we have a very inefficient, very constraint heavy prompt here. And that should definitely change. I will be experimenting with that next. So Pydantic is a really great library that helps, or it's a library or it's a framework, I guess, that can help guide the outputs to be structured. But this only validates after the fact, and it actually cannot prevent the model from generating the malformed structure in the first place, just in response to being overwhelmed by the prompt itself. So my takeaway is that, yeah, structured output for offline LLMs should just be rules-based as much as possible. And if you can, just allow the model as much freedom as possible to respond naturally. And then you just parse and reshape afterwards. So otherwise you might end up with my situation where you're practically writing the entire list of grammar rules as a fallback anyway. So very inefficient. And as for the main architectural challenge, it comes down to the main lesson that's from Tilbot as well, which is just choreographing syncing between the local and the cloud environments. especially if you don't want files to just be read only. So I would really like the option to be able to manage duplicates, or even introduce more notes into the flashcards from my phone, let's say. And so in that respect, I have a lot to fix with this project. So this whole thing is still quite a mess because the local index DB, so this is the local database, and then the one in the cloud, they actually have kind of different schemas. They have different timestamp conventions. And so the edits and the deletes don't propagate very clearly. And then the bidirectional syncing is also complicated by the fact that this is inefficiently a polling architecture versus an event logged one. So that just means like as long as it's online, we're just like pummeling every 5 minutes the server for any updates, just like a really eager golden retriever. Um, and then actually the main problem is a pretty foolish one, which is that I have it for now so that when the PWA is fetching cards from the cloud, um, only cards that are marked as not deleted are retrieved, but that actually means that anything that's been marked as deleted, this kind of soft delete, doesn't actually get finalized because the signal is missing. So I basically accidentally programmed a like out of sight, out of mind logic. Um, but even if the sync is not perfect yet, already this architecture is yet another template for me to think about what kinds of artifacts I want an LLM to generate and how those artifacts should be accessible. So in this case, with the Spanish flashcard app, the artifact is a set of verb and sentence cards. But I think the same architecture could support, for example, personal health assistance. I'm imagining like a health assistant that could process patient data offline on their own machine, but then generate a concise and highly tailored set of questions that you could take to a clinic and ask your questions with confidence. And so the separation between heavier private computation and lightweight multi-device accessible artifacts is exactly what this architecture makes possible. And so I'm hoping to iterate on that too. I have one final note, but I'm also wonder if I'm out of time. How
Yeah,
am
we're a
I
few
out of time?
minutes over.
Oh no, then I'm good. I just had like a next question direction. That's all. But it was going to go into a realm of something that I haven't worked on quite yet, but it's just, now that we've worked on like okay, data capture and then generating content, the logic next step is just like, oh, can I get an offline model to actually help me orchestrate and coordinate and co-think? And so I was just going to get into model
Yeah, yeah,
context
yeah.
protocol, but I don't have anything on that yet aside from my own speculations. But yes, thank you
Musings.
so much.